material delivery is done usually by postal, and these materials are usually two envelopes, the votes or the blank ballot, and also a credential that needs to be included also with the vote. So since the election commissioner, when they receive these votes, they need to discern if votes are coming from valid voters or not, so eligible voters. The voting process consists of marking manually on the blank ballot which are the preferences of the voters. And then we have two envelopes. The first envelope is protecting the privacy of the vote, so the voters need to put this vote in the first envelope. And a second envelope that voters put the first envelope and also this credential that says that this voter is eligible to vote. And finally, the vote return is done by taking this second envelope that contains all the election material and go to a postal office and give this vote to the postal service. The postal service delivers then this vote to the electoral officers. And finally, the counting process consists of open the outer envelope, check the credential. If the credential is valid, then take the inner envelope and put in a ballot box and later count. Okay? But which is the main problem? Which are the main issues in these cases? Why the different governments are thinking about using technology on remote voting? The first part in the materials delivery, what is happening is usually the materials are lost during the delivery, arrive late, arrive maybe in a wrong place or damaged, so voters cannot vote since they did not receive these materials correctly. Okay? During the voting process, another thing that usually happens is the voters maybe make mistakes in the votes. They are not aware of these mistakes, and when the votes are unfolded, when the election commissioners get access to the contents, then see that the votes are not valid, so these votes are not counted for errors that maybe are not valid, they are not forced errors by the voter. During the vote return, the same problem, delivery problems could happen. In addition, in some countries, voters, especially when we are talking about voters that are living abroad, these voters need to pay the delivery of the vote. And during the counting process, what could happen is that the votes are invalidated due to mistakes or are damaged, etc. So there are several issues that are present during the postal voting process. For instance, in the US in 2007, they made an analysis about the overseas voters, military voters, and they discovered that more or less 30% of the voters that start the registration process finally cannot vote due to all these problems. So they start to think about alternatives to deliver these votes. There are several ways that or several things that can be considered, like tracking, putting tracking numbers on the postal vote so voters can check where is the vote, if this arrived on time or not. The problem is that this could be useful when votes are sent to the voters, when voting materials are sent to the voters, but when the votes return the vote, the problem is that these tracking numbers are not solving any problems during the transport. So if the voters are aware that finally their votes are not counted, then it's generating frustration to the voters. So at the end, then governments like USA, like other governments, were start to think about, okay, we need to introduce maybe technology to improve these issues, so to solve these issues. So which kind of technology? We can think technology first to improve the postal voting channel, or another alternative is to look for a different voting channel completely based on internet. And in this case, we are talking about electronic voting. Okay. So if you focus on which kind of technology is used to improve the postal the postal delivery, if thinking about how the materials are delivered, we have the blank ballot delivery that I have seen that it's also known here as e-postal ballot. And in this case, it's just sent or allow voters to download or send by an electronic means a vote that can be printed at home. If we introduce technology during the voting process, this is also possible using what is known as online ballot marking, and that means that we are not, the election commission is not sending any blank ballot in PDF format, but what is done is it's offered to the voter some sort of web interface that the voter makes the selections, and then after this, a vote is printed that can be printed and sent, for instance, through postal. We have also the delivery, also can be done online, or putting barcodes on the paper, so it can be easier for counting. An alternative voting channel is internet voting, maybe. Okay, and internet voting combines all the advantages of the previous one, and usually there are governments that the approach that they are using is they are starting with introducing these improvements to the postal voting process, voting channel, that is more that is like a first step to introducing internet voting. So it's easier since they don't need to change the electoral law, so they are preparing then the introduction, they are like the first step to introducing internet voting. So more or less a quick highlight of the different process. E-postal mainly is voters needs to connect, to provide some sort of credential to the Electoral Commission, the website, and if the credential is valid, then the Election Commission can send a PDF that contains all the materials, the 2 envelopes, the credential that is required for casting a vote, and a blank ballot that needs to be marked by hand. Voter prints everything and then sends everything back through the postal channel. With this approach, then we are solving the main issues of the postal service when the voting materials are sent to the voter. The online ballot marking, as I said before, is not sending a PDF file. What is showing is a web page that the voter can make all the selections. And when the voter decides to cast the vote, what is done is there are 2 possible options. One is that a PDF file with the blank ballot with all the marks of the voter is generated, so the voter can print this PDF file, or it's possible to print directly the vote with all the marks that are done by the voter. Which is the main improvement in this case? If the voter is making any mistakes, then it can be detected in advance, and the voter can be warned about, okay, you are selecting too many candidates, or so it prevents, for instance, that the voter is doing mistakes that could invalidate the vote. Also, that can make the process more accessible to blind voters or any other voters that have some kind of disability. The online ballot return consists on if we have a PDF file, then we can return it back using the same internet channel. In this case, it's possible to do it using a web interface, or there are other alternative channels like email. There are other counties in the US that they are using fax, but usually it's considered the online ballot return usually is sending back the PDF with the selections made by the voter through internet. So this solves any issues that could happen during the delivery in the postal service. And internet voting, what it's doing is combining all these properties. The advantage also of using internet voting is we have been discussing here about using end-to-end verifiable voting systems, etc. This kind of system requires to implement some kind of cryptographic protocols that are difficult to implement when we are talking about PDF files, for instance. I will talk later when I'm talking about security, but in these cases, if you have a PDF file, maybe it's more difficult to generate the proof that the content is valid, since sometimes we need to represent the information in a mathematical way. So internet voting, one of the advantages is that then enables also to use these end-to-end verifiability mechanisms that are also making the elections more transparent. So, well, this is a summary table about which are the advantages that can provide the different approach. Also, online voting can improve the counting, can accelerate the counting, since we are using votes in electronic format. So it can be, the counting process can be faster and auditable. Some references. These technologies are already used in different countries. All the technologies that are related about how to improve or to enhance the postal delivery are mainly implemented in the US. And for instance, e-postal, or also known as blank ballot delivery, is currently implemented in 24 states in the US. Okay. The other 26 and the other 26 are still sending this, but using email or fax. Okay. In the case of online ballot marking, from the 24 states that are using e-postal, we have 15 that they are also offering the opportunity to implement, to select or to generate the vote by online ballot marking. So they are providing accessibility to the voters, and they are also preventing the voters from making mistakes. And in the case of online ballot delivery, there are 2 states currently that allow also to send back the vote in the PDF vote with the selections made by the voter through a web channel. There are also 31 states that allow to return the vote by postal or even by fax. From them, only 17 are offering the return by postal only. And in the case of internet voting, we are talking about 17 countries use internet voting on government binding elections, so it's not something that is starting. We listen here several times that Estonia is one of the countries that use it, but also I can mention the case of Switzerland, that they started in 2000. In fact, they introduced internet voting before Estonia. The difference is that Estonia introduced internet voting in the whole country. Switzerland started doing little steps. They introduced at the beginning in 3 of the regions of Switzerland that are cantons. But the first binding election there was in 2004. In Estonia was in 2005. Sorry. And also in Switzerland, last year, they also introduced a new law about how to audit and certify internet voting systems that requires that these voting systems are end-to-end verifiable. So it's one of the countries that are also now demanding the use of end-to-end verifiability on the internet voting systems. Otherwise, the cantons that are going to use internet voting needs to reduce. That needs to stick on the up to 30% of the population that can register to vote through internet. Other cases is Norway, that was the first one that introduced a voting system that has end-to-end verifiability and has been used in 2 binding elections. And France, it's another example about internet voting. In this case, they introduced internet voting for voters living abroad. And in the last election, I think that they are offering 3 different channels for voting for voters living abroad. And one is postal, the other is internet voting, and the other is that people can go to the consulate and vote in person. And currently, I think that yes, in the last election, 65% of the voters were using internet. And I think that only 1 or 2% went to vote in person. So currently, it's the most used voting channel in this community. So these are examples of technology that is used currently in different governments. So it's not something that is on testing, is used in binding elections. And what is important? Which are the important factors of using any kind of remote voting system? It doesn't matter if internet voting or if a process for improve the postal delivery. It's important to take account about security. So, which are the main requirements of security of this voting system? In one side, we have the voter privacy. So we need to ensure, in one hand, voter privacy. But on the other hand, we need to ensure that all the votes belong to valid voters. So it's a very requirement that fights one with the other. So in one side, we need to strongly authenticate voters. We need to be sure that the voters that are casting votes are really eligible voters. That only we have votes in the ballot box from diseligible voters, and that the privacy of the votes, the voters is preserved, not only when the votes are cast, but also during the counting process. Okay? On the other hand, we need to protect the integrity of the ballot box. You need to preserve the secrecy of the vote, so it's not possible to generate intermediate results. The integrity of all the votes that has been cast, it should not be possible, but somebody that get access to this ballot box to start to manipulate the votes or change the results. And the impossibility to add bogus ballots from, for instance, if somebody with access to the system says, okay, I know that 100 voters did not participate in the election, so I can add these 100 votes in the ballot box and then mark these voters. No, it should be possible also to detect these kind of practices. And in addition, something very important that has been mentioned several times today is verifiability. It's also an important factor, even in traditional elections. The traditional election is not only important, the privacy of the vote. It's also important that auditors, observers, people that are present in the polling stations can observe the process, that the process is behaving properly. So this is also important in internet voting or any kind of electronic voting. And also it's important that these measures are not allowing or making easier coercion of vote buying, since it's one of the issues or the risk of introducing remote voting in general, not only electronic but also postal. Okay. So let's start about remote voter authentication. In postal ballots, votes, usually the authentication it's based on paper that says, okay, you are a valid voter. So using technology is possible to improve this process, yes. Okay. It is possible, for instance, if somebody intercepts this information, for instance, using technology, you can use other factors for authenticating voters, not only a number of paper that is sent by postal. You also can send a one-time password through an SMS to the mobile phone, etc. So the use of technology can improve the authentication of the remote voters. Okay. So technology, it's an improvement in this area, considering the current traditional ways. Voter privacy. Okay. We have postal envelopes usually follow the two envelopes approach. So postal envelopes are preserving the voter privacy in terms that when the outer envelope is open, the election officers recovers the voter credential and another envelope that is protecting privacy of the vote. However, how robust is this measure? If we consider postal voting, it's not impossible for somebody that get access, physical access to this vote during the transport to get access to the information. So the protection of a physical envelope is, well, it's not very strong. It could be possible to add additional measures like sealing or something like this, but the problem is that the more measures that we are adding, the more expensive becomes the postal process, and sometimes these measures can be also bypassed. If somebody has another envelope that has these measures but has not been used, it can just only substitute one envelope by other. So it's important to consider that there are limitations for preserving privacy just only using this double envelope approach. So when we start to think about, okay, let's use technology, the first thing or the first thought that have people is, okay, let's put an SSL channel. Is this enough for protecting the privacy of voters? No, of course not. One thing that is very important when implementing some technology to protect the privacy of the votes is that the encryption is done in the same voting terminal. SSL channels are also recommended, of course, but it should not be the only measure used for protecting the vote. Otherwise, if this channel is broken, things happen several times, then it's possible to see the communications in clear. Additionally, the vote needs to be encrypted end-to-end, from the voter to the electoral board that is going to decrypt this. So it shall not be decrypted in the servers. So the privacy of the voter needs to be decrypted end-to-end the same way that is protected in an election. Only the electoral board members can open the envelopes. The same should happen in an electronic election. Additionally, we also recommend that the votes are digitally signed in the same voting terminal. just to preserve privacy. If we are just encrypting the votes with the public key, it's easy to substitute one vote with another. You only need to encrypt a different vote with the same public key and then makes this substitution. If you are digitally signing the votes in the same voting terminal, then you are preventing this to happen. Why? Since if somebody tries to make this substitution, then invalidates the digital signature, it can be detected, and then this vote can be discarded. Okay? So we are encrypting the votes in the same voting terminal. Is this enough from the election point of view to preserve voter privacy? No, still no. Why? Since we still have the decryption process. If we have a set of votes that are encrypted in the voting terminal, we don't think that is impossible, completely impossible, or 100% impossible to trace back an encrypted vote to the original voter. Nowadays, logs, some things, a lot of things are storing traces that maybe at the end you can trace back an encrypted vote with an IP address, and maybe you can guess who is this IP address, or you can guess which is the moment, the hour that this vote has been cast, and then you can correlate this with a real voter. So it's important that the votes are not decrypted and straightforward. It's important to add some sort of anonymity process during the decryption that prevents the correlation of the decrypted votes with the original order and therefore the original voters. Okay? So anonymization of the decryption process is important. Additionally, we also recommend the use to multi-party computation. That means that enforce the collaboration of more than one person at the same time for decrypting the information. So there is not a single person with the complete power of decrypting things. We need to distribute this with different members, and if it's possible, these members should have different objectives. So if we have, for instance, different members of the political party, we know that they are not going to collude. Okay? So this is important then to introduce this kind of multi-party computation, this kind of threshold decryption that requires the collaboration of different members. So when we are talking about anonymization schemes, well, there are more or less different families. We can summarize in 4 mainly. But what is important is from these families nowadays, the cryptographers are focusing on 2 that are homomorphic tally and mixing. Okay. It's also important that to highlight that the use of these schemes, these cryptographic schemes, are designed for internet voting, not for postal or for postal voting or returning postal vote, etc. Since they ask for having special properties on the cryptographic algorithms, like homomorphic properties, that then conflict with the fact of using any kind of information. Sometimes you need to have a special format of the vote for getting all the power of these properties. Okay? Mixing, I'm going very fast. The idea of mixing is similar to a traditional election. When you are in a polling station, you have all the votes in a ballot box, and if you open the ballot box carefully, you know that the top vote is from the last voter. So it could be possible that when you open this vote, you can correlate this with the last voter. The idea of mixing is that do the same as in a traditional election. Shuffle first the ballot box and then open. Okay? And the idea of the mixnet is to shuffle all the votes using random permutation. In addition, there is a transformation, a cryptographic transformation that could be a re-encryption of the vote or decryption of the vote that changes the ciphertext. So it breaks any possibility to trace back the new ciphertext with the original one. So it's preserving the anonymity of the permutation. But at the end, the idea is that when the votes are decrypted, what you obtain are decrypted votes, but in a completely different position from the original one. So it's not possible to trace back by the position, which are each vote with the original encrypted one. And therefore, it's not possible to correlate the votes, the decrypted votes with the original voters. Another possibility is to use homomorphic tally. I think that this has been also mentioned here. And the idea of homomorphic tally is that you have the encrypted votes, and instead of decrypting all the votes and then count based on the decryption on the decrypted votes, we can use specific properties of homomorphic algorithms that allows to perform the counting based on the encrypted vote. So we can operate the encrypted votes, and at the end of this operation, we have a ciphertext that we give to the electoral board. They decrypt the ciphertext, and magically we obtain the results. So it's a way for obtaining the results without decrypting the individual vote. And therefore, it's not possible to compromise voter privacy, since we don't know exactly which are the individual contents of each vote. We only know the final result. Okay. Vote integrity, I mentioned before that we recommend the digital signature of the votes in the same voting terminal. Okay? We recommend the digital signature of the encrypted votes, since the idea of a digital signature is similar to postal voting, that we have two envelopes. The inner envelope that is the encrypted vote is preserving privacy, and the digital signature is preserving the integrity of the encrypted vote, but also is providing information about the eligibility of the voter. So if for instance, we have digital certificates that have been issued for the different voters, and the voters use these digital certificates, if somebody wants to vote, needs a valid digital certificate. This voter cannot use another one. So then it's protecting the integrity of the vote, but also is providing eligibility to the vote. And here, usually there are two approaches. One is to digitally sign the votes in the same voting terminal, and digitally signing the vote in the same server. We strongly recommend to sign the votes in the same voting terminal. Why? Since once the vote is digitally signed in the voting terminal and using different digital certificates for each voters, then these votes cannot be manipulated. Otherwise, the digital signature will be invalidated. If the votes are digitally signed in the server, what could happen? Okay, if the server is compromised, then the server can change the vote before digitally signing, and therefore it's impossible to detect if the vote has been changed before or not. Additionally, if the server wants to add additional votes from voters that did not participate during the election, since the server can create and digitally sign new votes, it's possible to add this, to perform this kind of ballot stuffing practices in case that the server is compromised. If the votes are digitally signed by voters, the problem is that the server cannot do this, since it requires to have the digital certificates of each individual voter, and therefore it's not feasible. Coercion resistance. One important thing in remote voting, one of the main concerns is family voting or vote buying or coercion. This is something that is present, this risk is present usually in a kind of remote voting, since we don't have this supervised environment for casting votes. So one of the advantages of adding technology is that it's possible to add some techniques that can reduce or can make more difficult coercion or vote buying. For instance, multiple voting. If you have a coercer that is coercing you for casting a vote, the internet vote informs the coercer, you can cast a vote, and when the coercer goes, then you can cast another one. The last one, it counts. Okay, so we are adding here some sort of uncertain. Well, it's not certain for the coercer that the vote that has been cast in front of him is the one that be counted, but the voter controls this. Okay, and this has been used in Norway. Is also used in Estonia, and is a measure for preventing coercion. In the case of Norway, it has been also used in case that when the voter verifies the vote, since in Norway it was possible for the voter to verify if the vote contains exactly the intention of the voter. If the voter detects any problem, then the voter can say, okay, I'm going to another place and I cast again the vote. I know that the last one will be counted. So it's a way for, in case that the verification shows that something nasty happens and the vote that is stored in the server does not contain the selections made by the voter, then the voter can cast another vote. Okay. Another approach is to use to provide voters with a set of fake credentials and one valid one. So can use a fake credential in front of the cursor, that this fake credential is only casting a vote that will not be counted, and the correct one when he stays without anybody pushing this person to vote. So. And verifiability. I'm going to talk here also very fast since it has been talked several times here. Standard cryptography is not providing verifiability. Why? Since the main problem with standard cryptography is how can we ensure that if there is any malware in the voting terminal or malware in the server, it's not changing the information before it's encrypted. Maybe a voter is casting a vote and the voting terminal and the computer of the voter say, okay, you cast a vote for this candidate, but the computer is encrypting a different candidate. So it's important to verify that the encrypted vote that is received by the servers really contain the voter intent. And in the other hand, during the decryption process, it could be possible that you have a ciphertext, maybe you have some sort of virus in the decryption server, and the decryption server says, okay, the content of this encrypted vote is candidate B, but maybe it was A. So how it's possible to detect that the decryption process is also is not cheating? Open source. Okay, open source. There are people that say, okay, publish the open source. This is, and then we will check that the voting system is not implementing any nasty thing. Well, open source is providing transparency. It's allowing people, for instance, to see that the quality of the code is correct, etc. But cannot ensure that at the end, in the voting terminal, when the voter is casting a vote, the same code that is executed there has been obtained by compiling the published source code. So it's important from the point of view of transparency, but it's not enough from the point of view of verifiability. So if we want to provide verifiability, we need to move to advanced cryptographic protocols and generate verification proof that the different cryptographic steps are implemented properly. So let's see how can we approach verifiability on internet voting or electronic voting in general. If we consider a traditional election, everything is happening, is done by tangible elements. Auditors, the same voter, can audit the process by human means. So it's very transparent. When we move to postal vote, the main problem that we have is that we are losing some part of verifiability. We don't know what is happening during the transport of the vote during the postal service. Maybe the voter is aware that, okay, that the postal vote that gives to the postal service really contains the selections made by the voter. However, once this vote is in the postal service, nobody knows what is happening there until it arrives maybe to the Electoral Commission, and then auditors can be there just checking that the Electoral Commission is not manipulating anything. But in the middle, who can audit a postal service? Okay, so here we are losing verifiability. If we move to an electronic voting environment, since everything is happening in a logical dimension, it's not possible to audit things by human means. We are in front of a computer, we maybe see the computer screen, but we don't know what is happening inside the processor, inside the memory. So we are losing this verifiability, this physical verifiability. So it's important to identify which are the different requirements of verifiability that needs to be implemented in electronic voting, and then look for ways for implementing it. Usually, the classification of verifiability processes can be done by two different ways. One is based on what is verified. Then we have casus intended when what we are verifying is that the contents of the vote really contains the selection made by the voter, so the vote is casus intended. We have recorded as cast, that then means that, okay, I want to verify that the vote that I give to the electoral board, to the electoral commission, is really stored in the ballot box, that they did not discard after I verified the contents. And then we have counted and recorded. That means that during the counting process, nobody is doing any nasty things and is manipulating votes and substituting votes by the others. So it's possible to verify that at the end, the results really represent the contents of the encrypted votes. There is another verifiability that at least in Europe, it's also considered that is eligibility verifiability, that it needs to be possible to verify that all the votes in the ballot box belong to valid voters, that nobody is adding votes, additional votes, or voting votes, or vote vote. If we think about from the point of view who is verifying the processes, we have individual verifiability when the process only can be done by the voter, or universal verifiability when the process can be done by anybody. So it's not required to be a voter or even to be a member of the electoral board to verify. So it's not require any special access to the system or a special role in the system to audit the process. So it can be done open. It's possible to do verifiability. Well, I'm going to put here some examples about how we implemented verifiability in Norway. In Norway, we implemented verifiability using an approach that is known as return codes. Mainly are three different approaches. One is using return codes, another is cancel that is used by Ilios, and another approach is the download and decrypt that is the one used by Estonia, I think. And also it has been used by iVote system in New South Wales. But the one that we use in Norway consists of giving to the voters some verification card that contains all the possible candidates and parties with codes. Usually the codes are 6 digits, but in the case of Norway, we can put only 4 digits. And why is important this verification card? Since during the voting process, the voter votes as usual, is using the web interface, is selecting the candidates, etc., cast the vote, and when the vote is cast, is asked for, okay, if you want to, you need to introduce the verification, number. Well, here is the number that is here. Okay, so it's a unique number that is different for each voter, different for each card, and all these codes are different also for each voter. Okay, so this is an example. So if the voter wants to verify, introduce this number, and then as part of the voting process, the encrypted vote is sent to the server. Okay. And the server then performs a cryptographic operation. The other server performs other cryptographic operation. Both are done over the encrypted vote, so it's not any of the servers know exactly which are the contents. And the result of the operation is sent back to the voter. For instance, truncate only the 4 last digits, and can be sent, for instance, in Norway through SMS, through a completely different channel. So the voter can check if this number is correlated to the candidate it has selected. If the contents of the vote is a different candidate, then the number that will be generated, since everything depends on the contents, then will be the code for this other candidate. And then the voter can detect, okay, this code does not belong to my selection, so in the case of Norway, the voter can vote again. We are also working on this in Switzerland. Okay, so this is the voter receives this receipt number, and they can check it to this verification card. We are using also this in Switzerland, and in this case, since multiple votes is not possible, there is a confirmation code that if it's not sent, this vote is not counted. Okay. Recorded as card verification, in this case, what is done is each time that a vote is accepted and stored in the ballot box, a fingerprint of the vote is put in a bulletin board, is public completely, and the voting terminal generates a voting receipt with exactly this fingerprint. That is the fingerprint of the encrypted vote. So during the election, all these fingerprints are public. All the voters can go at any time and check if the fingerprint is present, so it's possible to check that the vote is present in the ballot box. And the part related to counted as cast, well, we are using a verifiable mixnet. In Norway, we use a mixnet that we developed, a new concept, and also we use in parallel with the Verificator mixnet. Both mixnets are verifiable and generates proof of the shuffling process. So it shows that during the shuffling process, nothing changed the contents of the vote. And also it generates proof of the decryption process. So it's possible to trace that when the votes are decrypted, nobody is also manipulating anything there. The tools are present, the protocols are present, algorithms are public, everything is public, so it's possible for anybody to make tools for verifying things, these things. The approach used in Norway was the election officers say, instead of publishing everything, they say, okay, the bulletin board is public, but this proves what the election commissioner, the electoral commission did is they made a public request of people that want to participate in the audit process in open way. So instead of publishing there, they say, okay, they prefer to follow a similar approach as in a traditional election, that they have observers, that anybody can apply for observer. They don't put any restriction. The problem is that nobody applied. They had only auditors that they say, okay, we are going to do this. They hire a different company, not Citel, to develop the tools, and they check this proof in the same moment that the election, that the counting process was carried out. It was broadcast, since it is possible to check that this happened, since it was done in front of a lot of observers. And they check this proof, and when they say, okay, proof of okay, then the votes were decrypted, counted, the votes were counted and added to the final results.
Sorry for the interruption, but...
Yeah, and this is the conclusion is
okay.
important. This one is e-postal can be a way for introducing internet voting. Is if governments that are introducing internet voting, not directly but in different phases, usually start with e-postal. E-postal end-to-end encryption is important, anonymous preserving decryption, and end-to-end verifiability, and mainly that's all. Well, the idea is to come from transparency of out-of-box to a transparency of computers.